So we're still in 2.5. 2.5 was on implicit differentiation. Remember, when do we use implicit differentiation? So if you can't get the y isolated, you still gotta get y prime. Use implicit, which just means differentiated in whatever disastrous looking form it's written in. Go ahead and start differentiating. You just have to remember to chain on the derivative of y with respect to x whenever you're differentiating something with a y in it. And I think we made it through 2 examples the last time we talked about this, right?
Sort of. We're going to finish the second one.
We did, huh? That's
Oh, you said we were going
We should have had, I think on the last example, we had y prime was negative 3 over 2y at least.
Yeah.
Is the answer 3 times?
Yeah, we did.
Yeah.
We did that one. We got that.
Hey Casey, are we something? Great.
Alright, but the very first problem we had, and the second one was based on it as well, looked like that, right? So for example 3, what I'd like to do is go through this thing and find an expression for the derivative of y with respect to t.
Undefined.
It'll be there, it's there. What we've done already is we've found the derivative of y with respect to x. I think we did that in the very first example under this section. This is going to look very, very, very similar. The difference is we'll now not only have to chain on derivative of y, we'll also have to chain on derivative of x when we come across an x variable. Why did we have to chain on derivatives of x before we did this? We were differentiating with respect to x. So the derivative of x with respect to x is just 1. I guess technically you're chaining on a 1, but it's kind of silly to go and write that every time. You can. This time we're going to differentiate with respect to t, which means every time we have a y variable, we're going to have to chain on a dy dt. And every time we have an x variable, we're going to have to chain on
X prime.
well, x prime. Well, that's like the nickname for dx over dt, right? So let's do this. We can just differentiate term by term. When you differentiate y squared, what happens first? 2 comes down. The y doesn't change. And the power is technically 1, right? Right. Chain on the derivative of y. Now, I know we called it y prime when we were differentiating with respect to x, and that's fine. I'm going to be a little more formal about it here. I'm going to call it dy over dt. Typically, when you say y prime, you're implying with respect to x. It's kind of a nitpicky thing, but just to be clear, I'm going to specifically say derivative of y with respect to t. Y prime is a little more x-based, typically. Especially when there's x's in the problem.
Gotcha. So when it's dy over dx,
Yeah, it's a little more understood then. Plus. If we differentiate this, we're accustomed to this just being plain old 3. And sure enough, 3 is still a part of it. But what we're going to do now is think of it as pulling out the constant 3 and just differentiating x. And typically we think, well, that's 1. And it is when we're differentiating with respect to x. In this case, it is literally the derivative of x with respect to t. There it is. Set it. Equals, when we differentiate 10, it's 0. And it does want us to isolate the dy over dt. So we've done the hard part, now we just got to do the algebra. We're going to isolate this, so what do we do first? Sure, subtract that extra term. So 2y times dy over dt equals the negative 3 dx over dt. So then dy over dt, to isolate that, we're still going to have this negative 3 stuff. Not just 2, but 2y, right? And in certain problems, they might say, okay, well, dx is going to equal 1 and y is going to equal 5. And then you can actually plug in numbers and get a numeric answer. If they don't do that, then, well, that's as far as you can really drive this car.
Need more gas.
Or more road, depending on the situation.
Or if you don't have enough room, you just turn around.
Same direction.
You're stuck on a traffic jam.
Maybe your cat died that morning.
I feel like this conversation is going to go really fast.
Alright, one more example. We got this weird looking equation. X cubed minus x squared y plus 4y squared equals 1. We want to find derivative of y with respect to x. So we're back to differentiating with respect to x now.
This is y.
Yeah, if you want to call this y prime, that would be a understandable thing to do. It's y prime time. It's